So here's the original data set. And don't worry about the colors. I put this in here for the Python, right? But yeah, this is our data set. This person is 48, makes that much money, not married, one child, no loan, no mortgage. This person's female, so it's a single mom. This person is 40, male, income, married, 3 children, has a loan and a mortgage, has loans and a mortgage, right? So that's our raw data set, right? And let me just do this. I'm going to copy these two, age and income. I'm going to kind of replicate the example in the textbook. I'm going to copy them to this blank table here. Okay. And then in figure, you guys have your book with you? If you have your data analytics book, go to figure 5.3 and give me an idea of where the income cutoff is for the red cluster. It's on page 220. See where the income is cut off in figure 5.3 for the red cluster?
About 35,000.
Yeah, right. So what I'm going to do is I'm going to get rid of the middle column. What I'm going to do is I'm going to also preserve the original ordering. I'm going to bring this into.
See, we have a different ordering in the data.
Oh, you do?
Yeah.
Oh.
We don't have the order column, in fact.
You just have a CSV file, right?
Yeah.
Okay,
Yeah.
so in the original data set, insert a column A, you from Canada, insert a column A and then put 0. Is it the same numbers here?
No.
Ah, crap. What if I can do this? I'll put this in the chat, see if that works. It might work. Can you copy that? Copying that and paste it into Excel. Let me try it.
Yeah, worked.
Okay, yeah, cool, awesome. Copy that and put it into the.
It shifted the column headers, but if you just move it over one, it seems to work.
Mine didn't get shifted.
Well, then I copied.
Yeah, it did.
It did.
Yeah, because this one's supposed to be, and then just make this one center it and make it bold red, because that's the Python. That's how we had order it in Python, right? Okay, and then you can center. You can just go ahead and center it all, right? And then what you want to do is you want to copy the first 4 columns and then put it in a new sheet. And then center, and then delete female. Because the one in the book does the distances, the Euclidian distances. It does it using just age and income. When we do the Python code, we're going to do all the columns. You're going to do k-means clustering for all the columns. Okay. So the first thing you want to do is you want to order by income. Okay, so this is going to be the clustering that's done at the very end. So I'm going to show you the result first to give you the intuition. So first we're going to sort by, largest to smallest on income. Whoop, I didn't do that. Grab the, click on the income value first. So that cell on the left or the right is white, and then pull it down. And then this will sort by the last column. There we go. See that? Now, where was the income cutoff in figure 5.3?
About 35,000.
Yeah. So it doesn't look like 30,000 is included, right?
No.
Yeah. And there's how many red squares are there? 8?
9?
1, 2, 4, 6, 8.
Oh, yeah.
Yeah.
And then a red
Eight squares.
circle.
There's 8 rows here, right? So that's where that first one is. I'm going to color that red. Okay, then what about the blue and the green? What kind of separates them? Is it income? They're both low income, right?
It's like an age.
So it's the age. And what age is it about?
42, 43.
Yeah. So we're going to sort next by age. So now you need to do a custom sort. And you want to put, let's just go up here and make sure. Gosh dang it. Let's do this. We'll start at the bottom and go up. Now, notice I'm always sorting on the uncolored, the black part, right? You see that? I'm sorting only on the black part. I'm going to sort by income. I mean, like by age. So I'm going to click sort and then custom sort. Dang it. I want to see if it takes up my header name. You got to be careful of this. So sort, copy from the top down to just before the red, right? And then click sort and then custom sort. See what happens if you don't, oh, okay, that's weird. Man, the stuff is weird happening today. Okay, we're gonna sort by age. Okay, so 40, is 40 included? Maybe, if there's a 40, right? It looks like 40 is included in the purple. 40 is included in the purple, right?
Yep.
We're going to make that purple. Okay, and then we're going to make this green. So these are the clusters that the algorithm that he uses comes up with. This is the result, right? And so you might have a, when you do the Python code, I'm going to create a new column called factor. And it's going to create a zero, a column of zeros, a column of ones, and a column of twos. This is going to be the output of your clustering algorithm. So it's going to create a new column, and you're going to append it to your original data set. Okay, and that's going to be called the factor, right? Okay, and then you can recreate the graph. You can recreate the graph by doing this. If you highlight just the age and income of the purple part, you can do this. You can do insert, scatter, right? And then, here, I'll shrink this down a little bit. Copy this and paste it over here. Clicking on the edge of it, just pull this down so it just covers the green stuff. See that? And then copy it again and paste it here. And then make sure you click on the edge and you can just pull it down to the red, right? You see that? Now check this out. All right, you guys ready to be amazed? Copy and then click on here and then paste on top of it. Ooh, cool. Copy this one and paste it onto here. There's our graph, right? Our coloring's all messed up. Y'all see that? That's our graph 5.3. I'm going to change this to red by clicking on that. I wonder if I can change it to red. Oh, man. Okay. Right click. Oh, there you go. Right click, fill, and then change it to red. Oh, and get rid of the outline. No outline. You can change it to a circle too, but we're not going to do that, or a square. Then we're going to change this. We're going to change this to purple. Go Griffins, right? And then we're going to change this to green with no outline. And there's our graph, right? We can make these diamonds if we want. Marker, options. Diamonds in the sky. And that's good. That's good enough, right? So that's our figure. And you're going to create this figure, but you're also going to have a size. You're going to do it in Python so you can make it a size based on number of kids. Okay. All right, so let's get a little understanding what's going on here. Okay, so this right here is what? Oh, by the way, hang on a second. This clustering is done by calculating z-scores. Anybody know what a z-score is?
Is it a mean?
Well, what we do is we calculate the mean of this group. Oh, wait a minute. Yeah, we calculate the mean of the entire column. And that mean is what? 46?
45. Yeah.
46, right? And the mean of this column is what? 28,000. If we don't convert, if this is called standardizing, right? So what are we doing here? We're taking that observation 22 and we're subtracting off what? The average, right? And the average has units years. Years minus years is years. The standard deviation has what units here? Years, right? So we're dividing a difference of years by years. And so the z-score is unitless. There's no units for the z-score. Does everybody see that? The z-score tells you how many standard deviations you're above the mean. This 22 is 1.869 standard deviations below the mean. When you looked up in a z-table to get a probability in a normal distribution, you're using the standardized value, right? A standard normal distribution has 0 mean and a standard deviation of 1. So if I were to calculate the mean of this column, it would be 0. That's 0, right? Numerically 0. You see that? You have to go long ways to get some decimal places. That's 0. Excel has round off errors, right? This has mean 0, right? Because again, income, we're taking that 8,877 minus the mean and dividing by the standard deviation, right? What is the standard deviation of a standardized variable?
1.
1. Just like a normal distribution, right? It's essentially 1, right? Close enough. So the mean and the standard deviation are 0 and 1. And I think it's just because this isn't perfectly 0, so this isn't perfectly 1. But in theory, they're both 0 and 1. All right. Why do we do that? If we don't do that, the income will overwhelm the effect of age, right? So we need to standardize them. So if you look at these two values, you might think that this is extremely low, and this is not that low, right? But if you look at the standard deviation, the z-scores, this income is really not that low. It's not too far below its mean, relatively speaking. This is a lot low. This value is a lot lower than the mean, right? It's 1.8, 1.9 standard deviations from the mean. This one's 1.4 standard deviations from the mean. See that? And of course, these are positive here, right? These are positive. This income level is extreme. Well, relative to that age, this income level is 2.4 standard deviations above its mean. And this is only 1.6 standard deviations above its mean, right? So that's the first thing you want to do is you want to standardize these values. Okay. Once you standardize them, then you can do what? This is called the Euclidian difference, right? This equation This equation is on page 216, where it says D Euclid. You see that? But there, we're taking the difference between 2 points. Here, the Euclidean difference is the distance from this point to the mean of this group, right? You see that? The average is a sub-average, right? We're taking the average of the group. You see that? We're taking the distance from this from the group's average, right? And these are going to be positive or negative, which is why we square it, right? So that's going to have units. Well, it's not going to have units. There's no more units here, right? So this is going to have, it's going to be positive because we're squaring the average is what? The average is 0, right? The average is actually 0. No. Yeah, no. The average might be close to 0, right? It might be close to 0 because the average of this is going to be different than the average of the entire series. So it's probably going to be pretty close to 0, right? So you take the difference of this value from its average of this group average, you square it. It's like the Pythagorean theorem, right? A squared plus b squared is c squared. And you do the same thing with income. You take this value in the group and you subtract it from the average of the group and you square it. And then you take the square root of it in total, right? So this is the Euclidean difference. This is the Euclidean distance to the means of the group. And you do that for each one of these. Yeah. How the point moves. We're taking the difference, the Euclidean difference from each point, the mean of the group. Right? And then this right here is the average of those distances, right? This is the averages of those differences. Okay, then down here, what do you got? You got a different group mean, right? You got a different group mean. And then you got a different group mean over here, right? So you're just doing the same thing, but within this group. See that? This is called the Euclidean difference. And then you just take the average of those. Then you got a third group down here. You see, your K here is 3. 3 means clustering. And this is the result of the algorithm. This is the final result of the algorithm. Okay. I think I can delete this here. I don't need that. Okay, now this is what's called the Manhattan difference. What do you have here? You have the absolute value of the difference. So you have the average of the group subtracted from the observation. And this happens to be negative, but when you take the absolute value of it, it becomes a positive. ABS is the absolute value. So that's what you have on page 217. D-man, right? D-man UV. But there is 2 points. Here it's 1 point from the average. So we're doing the Manhattan distance from the mean of each point in the group, right? See how that works? We're doing the absolute values. And are they pretty close to what you see over here? They're kind of close, right? There's a strong correlation, right? When these are low, these are low. When these are high, right? So there's a strong correlation. And notice what the average is. The average of the Manhattan differences is slightly greater than the average of the Euclidean differences. Basically, Euclid and Manhattan got in a fight, and Manhattan won, right? And we do the absolute differences from the averages of the groups here too, right? And then we do the differences from the average of these groups, right? for the 2 variables. If you have 3 variables, then you have 3 in the sum, right? Y'all see that? And then the average is here. You know, there was a mistake in the textbook. The 19,475, that corresponding value in the data set I downloaded from the website was actually like 17,565. So the data set doesn't actually exactly match the results in the book. Now, if you go to page 220 in table 5.2, average distances within clusters, notice that this 0.84 is pretty close to 0.886, right? And that's cluster 1, which is the purple group, right? And then cluster 2, or cluster 3 is the green group. And cluster 3 is the green group. And this is pretty close to its number of 0.73. And then this is the red group, cluster 2. And it's pretty close to 1, right? Y'all see that? Then go to figure 5.4. See the number of clusters, 3? When you have 3 clusters, you have 3 means. We have 3 clusters here, right? We have 3 means. The round dot on the solid line, not the X on the dashed line, where's that height at for number 3 clusters? Where's that height at, approximately?
35.
For number of clusters
Oh,
equal
2.
number of clusters equal to 3?
Oh, 10.
Well, not the red X,
Oh,
the dark circle. What height is that about?
13.
13 or 14?
Mm.
Okay, so that right there is a sum of within sum of squares, right? Sum of within sum of squares, right? And what the algorithm does is it minimizes that. So it's like a linear regression. That's why they call it least squares. Least squares picks the alpha and the beta to minimize the sum of squared errors. But this isn't the sum of squared errors. This is the within sum of squares. So the way you do that is, check that out. This is the value here minus the mean. So it's the first part of this here, right? And then we square it, right? We square it. See that? We square it. So this is a square. The deviation from the mean squared, right? That deviation from its mean squared. You see that? So there's 3 groups here. There's 3 groups. All these things are the first part of the Euclidean difference right here. See that? It's just that part right there, right? And then we go to a different group, right? And we keep doing that until we get to the end down here. We're in that 3rd group. And we start over in the next variable. The next variable, we do the same thing, right? And we get down here and we're in the last group. So this right here is the sum of all those squares. Each one of these is a square, right? Each one of these is a square, right? Square. You have seen that Seinfeld episode? Can't spare a square. Don't have a square to spare. We got plenty of squares, right? These are all squares. We're squares. We're meeting on a Friday night from 6 to 9:20 doing data analytics. We're squares. We're nerds. We're geeks, right? These are all squares. And this is the sum of those squares, SS, right? But we have these groups, so it's sum of within sum of squares, right? Y'all see that? And these groupings, these 3 groupings here, no other grouping will get a sum of squares lower than that. No other grouping will get you within sum of squares that is smaller than that. That's how this algorithm works. And it's kind of how regression works. right? And notice that this value 14 is the height of that circle on the solid graph in figure 5.4 is 14, right? Y'all see that?
Mm-hmm.
Right here in that figure. The height, we have three groups, three means. The height of that dot is 14, right? Okay, so what you're going to do is you're going to do the Python version of this. But what Python's going to do, and I'll open it up real quick. So what Python's going to do, let me just download it. Okay, you want to put this code, you want to put that code in one Jupyter Notebook input box, right? And run that. And this is going to do what? This is our data set that you downloaded, right? It's going to do 3 clusters, but it's going to do all of the variables. It's going to do all of the variables, right? And this right here are the 3 means. These are the 3 means right there. And this are the factors, that new column. This adds that factor column, the zeros and the ones and the twos, right? This adds this column to our X matrix. And then this saves it as demo KTC1, not demo KTC, right? So this adds that column, right? And then this prints out the means, the 3 means, the 3 sets of means. Actually, there's 3 means for each variable. There's 3 means for age, 3 means for female, 3 means for income, 3 means for married, 3 means for children, 3 means for loan, 3 means for mortgage, and 3 means for factor. And this does what? It scatter plots age versus income using the size. Well, why did I add 1 to children? Why did I add 1 to children there?
The standard deviation.
Well, there's 0 children possible, right?
Mm.
So that size of that dot would be 0. And then I squared each of those, and then I divided by 50. Why am I doing all that? I'm over exaggerating on number of children to see an interesting story, right? And then this right here is the color by factor, right? And it's going to look exactly, well, it's going to look very similar to figure 5.3, but this k-means clustering algorithm includes all the variables. In our algorithm, we only included age and income, right? But this k-means is going to use all the variables. So this is an even more complex version of it, right? And then alpha gives you the transparency, right? And then, yeah, don't actually delete. You don't need to run that. You don't need to do that. So leave that hashtag. And you label it figure 1, and then the X labels age, and the Y labels income, and then you plot show, right? Now this down here, does this look familiar down here? GDP per capita, life expectancy, pop, color, factor. This is grabbing the data from WDI that you just played with, right? Y'all see that? And this code, as written, will produce that bubble plot with USA, China, and India, right? And GDP per capita versus life expectancy, with population as a size and continent as the color, right? So it's going to reproduce that. So what you're going to do after that is you're going to change the coloring from continent to factor. So you're going to copy, after you run it once to get the original graph, you're going to take this and you're going to paste it in here, and you're going to use factor. You're going to use factor. Okay. And I don't think you need. Oh yeah, you need this. When you're sizing by the fact, or when you're coloring by the factor, you'll need to delete all these hashtags, and I'll make sure that's in the directions. You have to do, when you're doing factor instead of COL, you'll need to change all these, because we're going to change red. I don't think we need to do that. Do we really need to do that? I don't think we can do this. No, we need to do that because we can't use red, blue, green, yellow in the k-means algorithm. It doesn't know what to do with, so we're going to change these to numbers. So everywhere there's red, it'll be changed to 1. Everywhere there's blue, it'll be changed to 2. So this is a replacement, right? If you see red, replace it with 1. If you see blue, replace it with 2. See green, replace it with 3. Yada, yada, yada. You replace black with 5, right? So the second time you run this code, you want to delete all the hashtags, right? And then this is going to do a k-means cluster on this where the words have been changed to 1, 2, 3, 4, 5 for the color, right? And then this produces the factors. It's going to be 3 means because maybe we have a mean for underdeveloped, moderately developed, and then highly developed countries, right? But you can run it a second time. You can run this a third time and change that to a 4, or you can run it a fourth time and change it to 5, right? And then this right here adds the factor to X, and this saves it as WDI1. So next week we'll open up these WDI folders that you create, and we'll build the plots in Excel. Okay, and this just prints the means and the factor column, right? So the first time, run it like this as you see it. The second time you run it, delete all the hashtags down here. Well, except for this one. You want to keep that one, right? You want to keep that one. And then just change this from call to factor. Originally, this is call, then change it to factor. And you'll see a different coloring, right? And I think it's going to be pretty interesting. I think this is the best way to understand how to create factors. And all you're doing with factors is creating a dummy variable, so your analysis is better. You may not know why there's groupings, right? You may not know why there's groupings. So you run an algorithm to try to figure out if there's groupings. Why would you want to group your data set? Why do you want to group your data set here?
You want to find how they're similar because depending on what the data is, you may be interacting with clients or customers in a different way. So you want to see which one's similar.
If this is a website, right, and you're new to the website, you enter your information into the website, and they know your age, and they know your income. They can figure that you're in this group, and then they can market you, right? See that? They can market to you. You're going to market these people differently. You're going to market these people. And these people are going to be marketed a different way, aren't they? Right? That's basically how Netflix, I think, does their algorithm. They basically do cluster analysis, and they figure out what cluster you're in, and then they put stuff in your queue that you might like because they want you to be using Netflix. If you're not using Netflix because there's nothing in your queue that's interesting to you, you might delete your Netflix, right? So that's what they're using the data for. They're clustering on you. Right? People who liked the Equalizer with Denzel Washington and Taken will like Born Identity, right? So they're going to put Born Identity in your queue because you're in the red cluster, right? You see how that works? They use this cluster analysis to figure out which group you're on, and then they market to you, or they put stuff in your queue. When you're on Amazon.com and you tend to buy diapers, guess what they're going to put in your queue? They're going to probably put formula in your queue, right? That's how this works, right? Well, I'm about ready to pass out. I don't know about you guys.
Well, I'm definitely done. I was done like 45 minutes to an hour ago.
Yeah.
But this was cool.
Yeah.
However, I ran the code that you did give us, and I'm already getting errors in it.
Okay.
Me too.
Yeah, share it with me.
Let me.
Yeah. The code that I shared for this here.
The code that was in that. The code that was in the notepad.
For Jupiter.
Yeah, for Jupiter.
For the first
what I can share with you?
Mm-hmm.
Okay, what you have to do is somebody open up their screen real quick.
Okay.
So the problem is this isn't in your users file. So what you want to do is everybody wants to do that. I should have mentioned this. What you want to do is this. The easiest way to put this file in Jupyter's kernel is to click on homepage and then click upload.
Mhm.
And then there it is right there. There's the first
Yep.
one, right? And then
Yep.
click upload and then get the other one. Oh, you already have the other one, right? You should already have WDI, right?
Maybe.
I don't think we ever downloaded WDI. We were just pulling it from your website. Never
Oh,
saved
yeah,
a
yeah.
copy of it.
Here, let's do this instead. I thought my name would pop up.
Sorry, Hal.
Oop. Yeah, slash Excel slash. Ah, crap. Oh, CSV. That's why. What? What I'll do is I'll post the file. I'll post the file on that same tutorial. I'm too
Cool.
tired to remember let me try this. Maybe I'm just entering it wrong. All right, we don't want to download that. So let me just, what I'll do is I'll load the WDI folder. That's easy. I'll just do that right now. So let me go to Canvas and edit. Yeah, good thing you guys tried that tonight, because you would have been cussing me out this weekend. Oh, by the way, my bracket is #1 on Dish and DraftKings.
What are you talking about? The Pac-12 lost all their games. I thought you wanted them to win.
No, UCLA's playing. No, I had UCLA dropping out after they lost to Gonzaga, and I had USC knocking off Oregon and USC losing to Gonzaga.
Okay.
Yeah, I had 3 Final Four teams in.
Nice.
So let me fix this. This won't take long.
So, Hal, for tutorial 3, I'm just now looking at it. The assignment is it to do both the Python piece and the Power BI? Because I think I only uploaded screenshots for the Power BI.
Hang on one second. I can't do 2
Oh,
things.
yeah, you're fine. It's late.
Right now, I can't do it.
Yeah.
I'm about ready to lose it. I'm just hanging on. There's a song by Kim Wilde, Just Hanging On. If you don't know what it is, you got to look it up. She was a one-hit wonder, but she was good looking, so I had a crush on her. So now you should be able to download that, and then you can save it. You can upload it to Anaconda, right, from your download folder. Okay, there it is right there. Yeah. So upload that to Anaconda. Now, going back to the other question, Tyler.
Yeah. So for tutorial 3, what we're supposed to submit, is it just screenshots of the Power BI?
You can do screenshots of the Power BI dashboards.
Okay. Is it?
Yep.
Oh, sorry. Is it the Power BI screenshots and the Python that we need to run also?
Yeah, just screenshot the figures, the graphs.
Okay.
It's all about visualization, right? So screenshot the 2 dashboards that we built, and then screenshot the figures that you produce with the code.
Okay. Did this change overnight? Because I
added it today.
Oh, okay. I was like, man, I'm not that dumb. I swear this wasn't there when I submitted it yesterday.
It wasn't.
Oh, shit. Okay, good.
It took me. I was so busy this week. It took me all week to get the tutorial finished, but it's all right. Remember the due dates. It might be marked late, but you're not going to get penalized for it, so don't worry about it.
Yeah, because I had already uploaded stuff, and I was like, man, I'm losing my mind if this stuff was there and I just didn't see
No.
it.
I added the download the tutorial3.txt, the demo
Okay.
demo ktc.csv file. I added that tonight.
Okay, so you pulled the fast one.
Yeah, I threw you a curveball. Which happens at work all the time, right?
That's true.
But your boss would be upset if you didn't meet the deadline, right?
Yeah.
Would your boss really seriously be upset if you missed the deadline?
Luckily I've got a pretty cool boss, and
Yeah.
so our stuff is pretty flexible.
Yeah. Well, I hear most of the tech companies in Utah, they have they don't have PTO anymore, but they have like this flex time. You can take, if you're burned out, you can take a month off.
Yeah, unfortunately I work for Goldman Sachs, so
Yeah. So
they don't care if I'm burnt out.
Yeah. Well, there's a big hubbub about the bankers, the new bankers at the investment houses in New York City about them being burnt out. Yeah.
Our CEO doesn't care.
Yeah.
Our shareholders don't care because the CEO is making them a ton of money, so nothing will change.
Well, and they're cronying up to the Treasury and the Federal Reserve, so they're not going anywhere.
Yeah, no.
If they make bad decisions, they get bailed out by the taxpayer and the money printing press of the Federal Reserve. So they're in good shape.
Not that they need bailing out right now. I mean, they're making tons of money.
Oh yeah. Well, any investment banking house is going to be making money because the Federal Reserve does a credit expansion with low interest rates, and now I think investment banks are privy to discount loans if they need them.
Yeah.
So if they need credit, if they need liquidity, they just go to the Fed and get liquidity all they want.
Oh yeah. Cheap, and the volatility in the market has been really, really good over the last year. In trade volume. So yeah.
Well, I think that's because the Fed has just printed so much dang money, and the Treasury's printed a lot of money with these stimulus bills, right? They've had to sell bonds, and then banks buy them, and then the Federal Reserve ends up buying them from the banks. So the Federal Reserve is indirectly or directly monetizing our debt, which is creating the inflation that we see in the stock markets, right?
Right.
Yeah. So Goldman Sachs you're working for the right company in this kind of environment.
Yeah, oh, for sure.
So cool, man. Well, I hate to be crazy, and you don't have to do it tonight, but it's still not working.
Oh yeah.
So
let's see.
Yeah.
Go ahead and share.
Hold on 1 second. Let me just make sure I'm not crazy.
Yeah, you're not. I'm probably nuts.
I'm having issues with the CVS file. That's what the error comes up for me. At least one of the errors.
Yeah, that's what I'm getting to actually.
Yeah, share your screen if you can. My eyes are fried. Even with the computer glasses, my eyes are fried.
Let's see, which one is it? Oh shoot, I don't even know which one it is. Oh, there you go.
My left eye's starting to twitch. I think my son's ready to go to bed too. He's tired. Okay, so let me check. Request remote control. Okay, so let's go to home. So I don't see the demo. Where's the demo file? Oh, there it is. So let's click on that. Okay, that works, right? So let's just make sure it's spelled right. Or we just copy it up here. And its code is right here, right?
Yep.
Oh,
it ran fine for me.
Oh, I know. You forgot to import the stuff. You have to import the stuff above.
Oh, okay.
Yeah.
Gotcha.
Yeah. Can you open up the text file?
You need that. I just pinged it.
Yeah. So go ahead and open up you need to put the import stuff up here.
Gotcha.
Because it doesn't know what PD is, right? Yeah, I probably should have included that. Yeah, sorry.
It's
No, it's
working now.
Yeah.
Well,
It's
I got
included.
it, yeah.
So do you have the text file, Tristan?
Yeah, so I believe, hold on 1 second.
I can't see it.
I'm grabbing it
All
right now.
those import lines, can you paste them in there? There you go. Now run it. Good thing I did that because I would have forgot to tell you to upload those files, right? That's a graph right there, right? It's
Yep.
a little different. It's a little different, right? Because we're using all the variables, right? We're using all the variables, right? You got 7 of them here, right? These are our dummy variables that split it up into the 3 groups, right? See that? Right, and then you could change it to 4 if you wanted to. If you wanted to play with it.
So do you want all of these codes in one notebook?
Yeah, look at this one. 4. It's basically splitting it out vertically, right? See that? That's 4 means. 4 means. So if you have a huge data set, you may want to use more clusters, right? I mean, this is only 30 observations. But you like how pandas is so cool? I got X age. X is the data frame, right? Then I got X children plus 1, because you have to add 1 because the minimum of children is 0. Otherwise, it would have a size 0. And then here's the factor, right? So this is what oh, yeah. So it's not exact to the book, right? It's not exact to the book, but it's pretty close, right? So you got high income, and you got middle income, and then you got kind of low income. And there's like a line here, see that? You can fit a regression line to this. You can fit a regression line to that, and you could probably fit a regression line to that, right? So these might be dummy variables you might want to use in a multiple regression to get this linear relationship here, this linear relationship here, and then that linear relationship here. So that's why you want to use clustering.